So let's pick out all the things we have in that question. First of all, we have the boy standing 20 meters away from the tree. Now, there is a picture in your GS2 book. Well, I'm assuming if you have read Longman, his general math, or any other book for that matter, where pictures were given, and you are to identify all the things that are vertical and all the things that are horizontal. You may find it, you may think this is silly, but it really, really helps to really recognize words, to be able to define. So a tree, can a tree be vertical or horizontal? If a tree is horizontal, it's no more a tree. It means it's broken, it's falling down. A tree normally should stand vertical. So you need a vertical line. You represent your tree with a vertical line. This is my tree. Having drawn a vertical line, they now said a boy stands 20 meters away from the foot of the tree. So identify the foot of the tree. Let's assume this is the foot of the tree. Let's call it point A. This boy is 20 meters away from A. Now, is the boy going to be vertically from 25 meters hanging, or is she going to be on the ground? On the ground. Is the ground vertical or horizontal? If your ground is vertical, then you should be running because there's something wrong, isn't it? Earthquake. So we will represent the ground by what? A horizontal line. So if this is the foot of the tree, then we have what? The boy is on a horizontal level. So this is the tree, the ground. And the boy is probably standing somewhere there. Let's call that B. And the distance between the boy and that is supposed to be what? 20 meters. Now, the angle of elevation of the top of the tree from a point 1.5 meters above the ground is 24 degrees. In this question, you need to find out what do we mean by elevate. I've already explained this during the concept. You look up. And before you can look up, you have to have a horizontal line. So for elevation and depression, the reference line is a horizontal line. So let's say this is the top of the tree. Call it C. To see the top, we need to look up from a horizontal line. Now, the point is, they said 1.5 meters above the ground. So let's say the boy is standing here. There is a point somewhere there that is 1.5 meters above. So we'll assume we have a point here above the ground, 1.5 meters long. It is from here that they gave us the angle of elevation. So at that point, we need a horizontal line from which we are going to look up. We need a horizontal line. So we draw the horizontal line, then we join that point to C. In other words, this is the horizontal line at that point. Looking up will mean raising your head to see the line joining you to see. So this is the angle of elevation, to elevate. And that angle was what? 24 degrees. The angle of elevation from this point, let's call that point D. From this point, in order to see the top of the tree, is 24 degrees. So what's the question? Calculate the height of the tree to the nearest meter. The height of the tree, by the way, remember, this is 1.5 meters above the ground. The height of the tree will come from here to here. So it's the whole of this distance we are looking for. Now, if this is the ground and this is just a line like this, these two lines are parallel. So here you have 20 meters because they are parallel lines. They are on the same level, so to speak. So we have a right, and of course the ground and the tree have to be at right angle naturally. At least we'll assume they are at right angle. So from this right angle, we can calculate between here and here. Let's call this point E. We can calculate CE. But to calculate CE, we look at what we are given. We have an angle opposite CE, and we have 20 meters. And we ask ourselves, SOHCAHTOA. So and ka have hypotenuse. There is no hypotenuse in TOA. We are not given the length of the hypotenuse. So we forget so, we forget ka. We are obviously in TOA. And I've told you, if you cross multiply, when you say tan is opposite of adjacent, when you cross multiply, O is equal to AT. In other words, the opposite side is adjacent tan the angle. O is equal to AT. So what we want here, CE is equal to opposite tan base, adjacent tan, which is 20. The adjacent is 20 and the angle is what? 24. That's all. That is all. So when you get CE, how do we get the, don't forget you want the height of the tree. So the height of the tree is CA or AC. Therefore, the height of the tree is equal to 20 times 24 plus 1.5 meters. So check on the table for what is tan 24 degrees. Just straight through checking. You don't need to go inside, unlike the other one we were saying tan arc. Now we want tan angle. The angle you will have them 0 to almost 90. So just look for where 24 degrees is. Read what it is on the side. So you get 20 times whatever tan 24 is 0.443. Okay, and then whatever you get, you add 1.5 to get the final answer. So this will give us 10.36 meters. Then again, read your question carefully. The question asked, you are supposed to give your answer to the nearest meter. 10.36 to the nearest meter is almost what? 10.5. To the nearest meter is 10.5. So we're going to make this 10.5 meters. Sorry, to the nearest half meter. The question is to the nearest half meter. So this is 10.5 meters. Anyway, I'm sure you'll be all right. So these are just a few examples on right-angled triangles.